So bubble sort is the sorting algorithm that basically gets no respect. Oftentimes, if you ask people what's the worst sorting algorithm that's out there, folks will say bubble sort, and it turns out that it's pretty inefficient. It is an n squared algorithm, much like insertion sort and selection sort, which we're also looking at. But bubble sort does a bit more work. So the idea with bubble sort is, imagine if you're playing cards and you are taking a look at. So you begin at the left hand side, the beginning of the array, if you will. That is what the outer loop does. The outer loop sets the card that is being positioned in this iteration. Okay, so even though we begin the search on the right hand side of the array, that is done by the inner loop. Okay, so the outer loop says I am going to find the card that belongs in position 0, in element 0 of this array. So you notice that it goes from 0 all the way to to less than n minus 1. So it actually goes to n minus 2. And the reason for that is that when we get to that end and there's only the card sitting at index n minus 1 by itself, it's already sorted and it's guaranteed to be in the right position. The inner loop begins at the end of the array, so it begins at element n minus 1. So all the way to the right of the array or at the bottom of the array, whichever analogy you prefer there. It begins there and it moves all the way until it is one more than I. And I again represents the sorted portion, so that as we add elements, initially I is set to 0. When that first loop, the first outer loop iteration terminates, then the correct card is in element 0. And then we bump up I to 1 and we try to position that next card. The way we position cards is to move all the way to the end of the array and move back toward the sorted portion, okay, which is gradually expanding as we go, and up to that portion, and then swap any data that we find, data j, to be less than data j minus 1. And I'll show you what that looks like graphically, and that will make more sense. Okay, so we will just swap those two. So here we are at this, and this is our array. It's, as you can tell, it's not sorted. And initially, again, what we're saying is we're going to find the card that actually belongs in this position. Okay, to do that, we move all the way to the end of the array. And if this value is less than the value to its left, we swap that data, okay? And then the counter is then here, and then we compare the 1 and the 3. Okay, so when we swap, we're not just doing pairwise swaps, we're staying with the one element of the pair, okay? So 1 is in fact less than 8, so we're going to swap those, okay? And now we're here, and now we have to compare the thing at j with the thing at j minus 1, okay? And we do so, and 1 is less than that, so we make the swap, and then we move and compare the 1 and the 2, and we find that the 1 is less than the 2, and we make the swap. And then finally, we compare the 1 and the 5. The 1 is less than the 5, and we make the swap. And so what we've done up until this point is actually position the element at location 0. Okay, So when we get here, we have positioned the element at location 0. We then increment I, which is the top value. We increment I to 1, which means we're trying to position the element here at this location. Let me make that more clear. Okay, at this location. And so what do? We move all the way to the end of the table. And we say, is the 8 less than the 3? It is not. Is the 3 less than the 2? It is not. Is the 2 less than the 5? Yes, it is. So swap the 2 and 5. And now we've reached this point. And so now here we position the 1. And now here we've positioned the 2. And our array looks like this now. And we now say, hey, I'm going to try to position the thing at element 2. Okay, so I is now 2. Okay, there we are. And so what do? We move all the way to the back of the array again, and we say, is the 8 less than the 3? It is not. Is the 3 less than the 5? Yes, it is. And so we make the change, and the rest of this is the sorted portion. So we've now positioned this particular element. Okay, now we set the value to 3, which means we're now trying to position, say, this guy, and we go to the end and we just say, well, you know, is the 8 less than the 5? It is not. So at that point, we nail that down, and so the algorithm at this point terminates because we're pretty much down to 1 value. And as you can see, we've gone from 5, 2, 3, 8, 1 to 1, 2, 3, 5, and 8, which is what we want. And so the data is sorted. Right, so why is this n squared? Well, it's n squared because I iterate through n minus 1 things, and potentially I have to do n swaps or n minus 1 swaps moving back. So that's n minus 1 times n minus 1. That's order n squared. Okay, so it's order n squared, and it makes that many comparisons and moves only the data that it must move.